This tutorial will help you to complete homework assignment number 13 on DeltaMath about scientific notation. Let's get started. The first concept is converting from a scientific number back into standard form. So you'll notice in this question here that the number is already written in scientific notation. We know that because we have a number on the left known as the coefficient, and we have a power of 10 here at the end. 10 to the positive 6th power is a 1 with 6 zeros after it. Or 1 million. So I want to multiply 5.5 times the number 1 million. So just think about that for a second. I want the number 1 million 5.5 times, so that means I'm going to have a pretty big number when I'm done. A shortcut to multiplying by a large power of 10 is to simply move the decimal point. So a decimal point can either move to the left or it can move to the right. Now this is a little counterintuitive, but if you think about this number 5.5, if I move the decimal one place to the right, I would get 55. If I moved it 2 places to the right, I would get 550. Now that's a little weird, but that happens because when I move the decimal 2 places to the right, I have an empty place right here. And when we have an empty place value, we use a 0 to hold its place. So let's think about 5.5 times 10 to the 6th. Well, 10 to the 6th is a 1 with 6 place values after it. So if I take the number 5.5 and I move this decimal point 6 times, 1, 2, 3, 4, 5, 6, then my new decimal point would be here. And it wouldn't be there anymore. But all of these empty places need placeholder zeros. So my final answer is going to be 5, 5, and then 1, 2, 3, 4, 5 zeros. Now I know you might be thinking, hey, it's 10 to the 6th. Shouldn't I have 6 zeros? But that's not correct. I should have 6 places, not 6 zeros. And since this number 5 was already there, it took up one of my places. So that's why I have 5 zeros and not 6. So before I delete all my writing, let's write down this number. So I have a 5, then I had another 5 after the decimal, and then I had 5 zeros. 1, 2, 3, 4, 5. And that is my final answer. Let's give it a try, and we are correct. So now I can clear all my markings off. Let's do another one. Okay, let's think about this one. 2.1 times 10 to the 3rd, or a 1 with 3 zeros after it. So my number is definitely going to be getting larger. 2.1 times 1,000. So I need my decimal point to be 3 places larger. Now don't forget, the decimal point has to jump past this number 1. So that takes up 1 place. I have to move 3 places. So I need to go 2 more spaces. And don't forget to fill in those places with zeros. So 2100 or 2100 is going to be my final answer. Now, in addition, you can also have powers of 10 that have negative numbers. Take a look at this one here. Now this one has a power of 10 to the negative 3. Now that doesn't mean I'm going to have a negative value. 10 to the positive 3 means that I have a 1 with 3 zeros after it. But 10 to the negative 3 means I have a 1 with 3 zeros after it in the denominator. So a negative power is actually a fraction. So if we think about this, 3.4 times 1 over 1,000, it's kind of like I'm dividing by 1,000. 3.4 times 1 is still 3.4. But dividing by 1,000 means I'm going to get really small. Right? So I'm taking 3.4 and I'm going to divide it into 1,000 different pieces. That's a really tiny number. So instead of actually dividing 3.4 by 1,000, what we're going to do is we're going to take our 3.4 and we are going to move it, since my exponent is -3, I'm going to move it 3 places in the negative direction, just like that. So my decimal point will now be way down here, and since I jumped 1, 2, 3 times, I actually have 2 placeholders. So my answer is going to be decimal point 0034. That's it. Let's try one more. Here we go. 7.9 times 10 to the -2 power. Remember, a negative power means that you are getting smaller. So 7.9 times 10 to the -2 power means move 2 places in the negative direction. 1, 2. There's my placeholder 0. So my final solution is going to be decimal point 079. Now remember, the number can get bigger or the number can get smaller. So in this problem, 10 to the +4th, the number is going to get bigger. In this problem, 10 to the -2, the number is going to get smaller. All right, let's take a look at the second task. The second task in this homework assignment is to write a number that is already in standard notation into scientific notation. Now, you are written in scientific notation if you have a coefficient, that's the number in front of the time sign, that is between 1 and 10. Now, you can't be 10 because 10 has 2 digits in it. So you have to be less than 10. You can be equal to 1 though. You can be greater than it or you can be equal to it. But you have to be less than 10 because the coefficient needs to have a single digit in front of the decimal. You can have any number you want, but you can only have 1 digit to the left of the decimal. Then you need a time sign, you need a 10, and you can have any power you want. It can be positive or it can be negative. So your coefficient needs to be between 1 and 10, but your power of 10 can be any value. And how you're going to choose whether the value will be positive or whether the value will be negative is depending on what type of number you have when you start. If you have a really big number, like 27,000, your power is going to be positive. If you have a really tiny number, like this one, where the decimal point is way over to the left, then you're going to have a negative exponent. All right, let's take a look at this. 27,000. Now, it doesn't have a decimal point, but it needs a decimal point right in between here. And if it doesn't have a decimal point, that means it was hiding at the end. So how does it get over to there? Well, it jumps 1, 2, 3, 4 places. So my power of 10 is going to be 4. And I know it's a positive 4 because the number I started with was bigger than 1. If your number is bigger than 1, then you have a large number with a positive power. So my new coefficient, though, is going to be 2.7, and I'm going to leave all those zeros off. So 2.7, and my power is going to be 4. All right, let's try this again. 910. 910 is a number bigger than 1. So the decimal point is hiding at the end. It needs to move over 91, 9.1, until I get a number between 1 and 10. Now when we write our coefficients, we leave these extra zeros off at the end. We leave them off. So my final answer is going to be 9.1 times 10 to the 2 power. 9.1 times 10 to the 2 power. My coefficient is 9.1. My exponent is 2. Let's submit our answer. Awesome. All right, let's take a look at this one. Look at my original number. My original number is 0.0032. Now that number is lower than 1. So that means my exponent's going to be negative. Now let's decide what the exponent should be. Well, the decimal point is here, but it needs to be between the first two non-zero digits. So 1, 2, 3. Now I don't move to the end of the number, because if I moved all the way to the end, the number would be 32. 32 is bigger than 10 and you can't have that. So I move 1, 2, 3 places, giving me a 3.2. 3.2, and my power of 10 is how many decimal places did I move? It looks like I moved 3, so my power of 10 is negative 3. So 3.2 times 10 to the negative 3. Submit our answer, and we were correct. Okay, last one. All right, so I'll take my decimal point, and I'm going to move it 1, 2, 3, 4, 5, 6. 2.9 times 10 to the negative 6th. And I know that because the number, when I started, was lower than 1. So 2.9 times 10 to the negative 6th. That's it. All right, let's take a look at the third and final section of the homework. All right, for this third section, you're going to need a calculator. So the question asks us to find the quotient. And that's when you divide. So 5.846 times 10 to the 7th divided by 7.9 times 10 to the 2nd. So here's the hard part, but it's really actually simple. You're going to split this problem into two. The coefficients is one problem, and the powers of 10 is another problem. Now we studied this earlier this year. When you divide powers of 10, the base stays the same, the 10 stays the same, but you subtract the powers. 7 minus 2 is 5. That's it. Now the 5.846 divided by 7.9, you need a calculator. I need a calculator, so you definitely need a calculator. Turn your calculator on. Type the numerator, 5.846, divide it by 7.9, and whatever that answer is, that will be your new coefficient. So 0.74. Now here's where it gets really tricky. This is the correct answer, but technically, the coefficient is not in scientific notation, and that's because the coefficient is less than 1. Your coefficient has to be between 1 and 10. So in order for this number to be between 1 and 10, I need that decimal point to move one place to the right. And if this side of the sentence is going to get one place value bigger, this side of the sentence has to get one place value smaller. So my power of 10 is now going to be 4. And my coefficient is now going to be 7.4 instead of 74. 7.4, and my power is 4. Awesome. Right? If you didn't quite catch that, you could certainly look over the example that they have here, how they broke the problem down, how they subtract the exponents, and how they rewrite their coefficient number. Now they show it a little bit differently than me, but they still move the decimal and they still moved the power. Now notice they're moving in opposite directions. All right, notice that they're moving in opposite directions. That's important. All right, let's try another one. This one is a product. A product is when you multiply. So 54, it doesn't have a power of 10, so it's 10 to the 0, times 2.2 times 10 to the 6th. So we're going to do 0 plus 6, because when you multiply like bases, you add. And we're going to do 54 times 2.2. Now you need a calculator. 54 times 2.2. Again, if your coefficient is larger than 10, you're going to need to do some fixing. I think it was 118.8. 118.8. 118.8. Now let's see, how many places does this have to move? This has to move 2 places smaller. So that means this one has to move 2 places bigger, right? They have to be opposites. It's This way, we're not really changing the number. If you remove 2 places but add 2 places, you've really done nothing. So my new coefficient will be 1.188, and my new exponent will be 10 to the 8th. That's a lot of 8s. Let's fill this in. 1.188 times 10 to the 8th. Let's check it. All right. Let's take a look at this explanation. Yep, we multiplied the coefficients. We added the exponents, 10 to the 6th, because there was only one exponent. And then we renamed the coefficient by 2 places, and that means we got bigger. All right, let's try another problem. A product. Right, a product is when you multiply. So I'm going to multiply 6.8 times 10 to the 4th and 9.3 times 10 to the 6th. That's going to give me 10 to the 10th. And let's get our new coefficient. 6.8 times 9.3. 6.8 times 9.3. 63.24. 63.24. Now, this one is 1 place too large, so get 1 place smaller. The power gets 1 place bigger, so that's 6.324 times 10 to the 11th. 6.324 times 10 to the 11th. That's it. That's how you complete homework assignment number 13.